Hi, friends, greetings, and welcome to our YouTube channel online. There is a question for us. I want us to look at this question. It was proposed to me by a student, and I want us to look at it. I want us to look at the full question. So the question is on complex numbers, and the question reads that the complex number z is given as z equal to 3 minus I over 2 plus I. We should express z in the form a plus bi, where a and b are real numbers. And the Roman 2 says, given that z is equal to cos theta plus I sin theta, we should show that z cubed plus z to the power negative 3 is the same like 2 cosine of theta. And they said, hence, we find the general solution of the equation z cubed plus z to the power negative 3 equal to 2 cos theta. Oh, I think there's an error here. Yeah, it's and this an error here. We should find the general solution of the equation z cubed plus z to the power negative 3 equal to 3. Yeah, I'm sorry about that. I'm sorry. Yeah, so please let's get started. Please, if you're new to our channel, please subscribe to the channel and like all our videos. Okay, we have enough videos in our channel already that are so beneficial. Okay, yeah, so explore them. Don't get to the examination room and only realize that there were videos that could help you pass your exams later on. Okay, yeah, so please I advise you to watch all the videos and give a thumbs up on all of them, because when you like the videos, you motivate us to produce more content for you. Okay, yes, so let's get started. The first part is saying that we should express z in the form a plus bi. That z is the same like 3 minus I. I'm just copying the question, which is 2 plus I. To express a certain complex number like this in the form a plus bi, all you have to do is just to multiply top and bottom by the conjugate of the bottom, because the conjugate of 2 plus I is 2 minus I, right? Because if you have a complex number as a plus bi or x plus yi, the conjugate is just given as x minus yi. Yes, so I'm just going to multiply by 2 minus I, here by 2 minus I, wait, such that I'm just going to have the top, I'm going to have 3 times 2, which gives me 6. 3 times negative I gives me negative 3i. Negative I times 2 gives me negative 2i. Then I times I is I squared. I times I is I squared, which is negative 1. But there are still two negatives, so at the end result, I still have negative 1. All that on this a complex this a there is a simplification for complex numbers which says that if you multiply two complex conjugates, or if you multiply a complex number and its conjugate, you are just going to have the sum of squares. So I'm just going to have 2 squared, which is 4, plus 1 squared, which is 1. So simplifying this guy, I have 6 minus 1, which is 5. Then negative 3i minus 2i, which gives me negative 5i. Then 4 plus 1 gives me 5. So this guy simplifies. If you divide all of them by 5, you just have 1 minus I. Great. And it's of the form a plus bi, where your a is 1 and your b is negative 1. Great. That's the Roman 1 of the equation. This is Roman 1. Then the Roman 2 says that given that z is equal to cos theta plus I sin theta, we should show that z to the power 3 plus z to the power negative 3 is equal to cosine of 2 theta. Great. So since they said my z is the Roman 2, since they said my z is equal to cos theta plus I sine of theta, and we should show that z to the power 3 plus z to the power negative 3 is the same like that. So I'll just raise everything here to the power 3. That gives me cos theta plus I sine of theta, all that to the power 3, plus z to the power negative 3, which is the same like cos theta plus I sine of theta, all that to the power negative 3. Let's simplify that. We are going to use the Morph theorem here. The Morph theorem tells you that if you have cos theta plus I sin theta, all that to the power a constant, you're just going to take that constant and put into all the theta values. So that this is just going to be cosine of, take 3 and multiply by the theta, which is 3 theta, plus I multiply by theta by 3 theta again, which is I sin 3 theta, then plus this 3 theta comes here, you have plus cosine of negative 3 theta, then plus I sine of negative 3 theta. Great. So we are going to have cos theta here, cos 3 theta, sorry, plus I sine of 3 theta, Then we know that cos of a negative angle is the same like the cos of the positive angle, right? Because the cosine function is an even function. So cos of negative theta is the same like cos theta. So cos of negative 3 theta is the same like cos of 3 theta. We have cos of 3 theta. Then the sine function is an odd function. The sine of a negative angle is the same like the sine of the positive. The sine of a negative angle is the same like what? Negative of the sine of that positive angle. Yeah, so it's just going to be negative I sine of 3 theta. Wait, we see that I sine 3 theta, negative I sine 3 theta, they are negotiating. So here we just have cos 3 theta plus cos 3 theta, which gives us 2 cosine of 3 theta. Great. So since it's a proof, we have to write as required. We can write a box and check. Okay. Yeah, so since it's a proof, you have to conclude, else you might lose marks. So that's it. And they said you should find the general solution of the equation z cubed plus z to the power negative 3 equal to root 3. Initially, they asked us to show that z cubed plus z to the power negative 3 was equal to this, right? So I can just replace all this result with just 2 cos theta, just what we prove. So to find the general solution of z cubed plus z to the power negative 3 equal to root 3, that implies, what is my z cubed plus z to the power negative 3? It was 2 cosine of 2 of 3 theta, right? Great. So this is equal to root 3. So we divide by 2 now, we are going to have cosine of 3 theta to be the same like what? Root 3 on 2. That therefore implies my 3 theta is the same like cos inverse of root 3 by 2, right? Which is cos inverse or arc cos of what? Root 3 by 2. What is the cos inverse of root 3 by 2? Perfect. That's 30 degrees, right? Yeah, 30 degrees. Or in other words, what? In other words, it gives us what? Pi over 6. You can put in degrees, you can put in radians. It's your choice, okay? Yes. So I have 3 theta to be equal to pi over 6. That's my principal value. So to get the general solution now, the general solution of a cosine function is given as 3 theta equal to what? 2n pi plus or minus the principal value, which is what? Pi over 6. That implies my general solution now, the general solution is given as, if I divide everything here by 3, I'm going to have my theta to be the same as 2 over 3 n pi, 2 over 3 n pi plus or minus, if you divide pi over 6 by 3, you're going to have plus or minus what? Pi over, you're going to have 6 times 3. What's 6 times 3? 18. All over pi over 18. Let me write it now in clear manner. We have theta to be equal to 2 over 3 n pi plus or minus pi over 18. Yes, so that's our general solution. That's the general solution. You can just see where n belongs to the set of real numbers. Set of real numbers. Okay. Yeah, great. So that's it. So please subscribe to our channel to get more tutorials like this. Subscribe to our channel. If you have any questions that you want me to attend to, I'll leave my WhatsApp contact in the description and my email as well. You can send it through email or you can send it through WhatsApp. And also follow our Facebook page. Okay, I'll put the links to the Facebook page in the description below. In the Facebook page, we also have tutorials like this. We have many more which are not on YouTube, and we also have scholarship opportunities that we advertise for you to apply. And the scholarship is for those who are in Form 4. That's those who are in Form 4, from Form 4 right up to those who are in upper seat, those who have their bachelors, those who want to have their bachelors, those who are doing masters, and those who are doing PhD. Okay, yeah. So if you are from Form 4 and above, the scholarship this is going to be a very nice fit for you. Okay, yeah. So see you, and please subscribe. Like I said, all the descriptions are going to be in the link below for your convenience.